Thermodynamics. Thermodynamics means flow of heat. Particularly in chemistry, thermodynamics deals with energy changes in the form of heat during a chemical reaction. So, the branch of science which explains the energy changes that takes place during the chemical reaction is known as thermochemistry, or sometimes it may be called as chemical energetics or thermodynamics. We know that in matter, energy is stored in several forms. We cannot determine the exact quantity of heat or energy that present internally in a given substance. But when substance converts from one form to another form, the difference in the internal energies can be calculated. That means, in a chemical reaction, a reactant, that means the species which is involved in the chemical reaction is said to be reactant, and the substance which is produced is said to be product. Now, reactant will have certain amount of internal energy, product will have certain amount of internal energy. It is impossible to determine the total amount of internal energy that was stored or present in reactant as well as in product. But when a reactant converted into a product, the difference in the internal energies may be determined. This is of two types, basing on the condition in which the change takes place. If we measure the change of internal energy at constant temperature, constant volume, then it is said to be change in internal energy. It can be denoted with delta U or delta E. If you determine the change in the internal energy at constant volume, the difference of internal energies, because reactants will have certain amount of internal energy, it can be denoted with UR or ER. And products will also have certain internal energy, UP or EP. These exact amounts of reactants and products' internal energies cannot be determined accurately. But when the change occurs, the difference of that internal energies can be determined. That change is denoted with delta U. By convention, delta U is nothing but internal energy of products final stage minus internal energy of reactants. That means or EP minus ER. Here generally in chemical reactions, the difference of energies will be liberated or absorbed in the form of heat only. Now, another way to measure the change of internal energies, that means sometimes the experiments, most of the time, because in our laboratory atmosphere, we'll conduct the experiments in open containers. When a reaction is done in the open container, that means exchange of mass and heat can take place. So that means the reaction energy changes is absorbed at constant pressure. So if you observe the energy changes at constant pressure, then the change is said to be enthalpy change. This enthalpy change is denoted with delta H. Delta H is Hp minus Hr, whereas Hp is enthalpy of products and Hr is enthalpy of the reactants. So, we can measure the energy changes or heat changes at constant volume or at constant pressure. If we measure the energy changes at constant volume, it is called as internal energy change or change in internal energy. It may be denoted with delta U or delta E. If energy changes, if we observe the energy changes, when the reaction is carried out at constant pressure. Constant pressure means the reaction which is carried out in open containers. The pressure is constant. In such cases, the energy changes is called as enthalpy change and it is denoted with delta H. So enthalpy change delta H is equal to Hp minus Hr. Enthalpy of products minus enthalpy of the reactants. That only we can measure. For example, if we take carbon when burned in presence of oxygen, it will give us carbon dioxide and liberates 92.1 kilocalorie of energy per mole. Here, carbon has certain amount of internal energy. Here, oxygen will have certain amount of internal energy and carbon dioxide will also have certain amount of internal energies or enthalpies. It is not possible to measure the internal energies or enthalpies of a particular substance in an isolated state. It is not possible to calculate internal energy or enthalpy of carbon. It is not possible to measure internal energy of oxygen. It is not possible to measure internal energy of CO2. But when carbon combine to give carbon dioxide, heat is liberating. So we can measure that heat, the total quantity of heat that was liberated. That quantity of heat which was liberated at constant volume, we call it as change in internal energy. If we measure it constant pressure, we call it as change in enthalpy. Now this enthalpy change is denoted with delta H. This delta H is nothing but Hp minus Hr. That means it is the difference between enthalpy of carbon dioxide and the total enthalpy of carbon and oxygen. The difference amount, here it was liberated. Some heat is liberated means here CO2 enthalpy is 92.1 kilocalorie less than the total enthalpy of carbon and oxygen together. So when we apply Hp minus Hr, it means it is a lesser quantity than the sum of the reactants. That's why in exothermic reactions, such type of reactions in which heat is evolved are said to be exothermic reactions. In hexothermic reactions, delta H and delta P values are negative. That means it can be represented as 92.1 kilocalorie. if we express the heat along with the reactants and products, we'll add a plus sign. But if you want to know, express in the form of delta H, you'll have use this negative sign for exothermic reactions. Because basing on the temperature changes or energy changes, reactions may be of two types: exothermic reactions and endothermic reactions. Endothermic reactions are those reactions in which heat is absorbed during the reaction. When heat is absorbed during the reaction, such reactions are said to be endothermic. That means in such cases, product's internal energy or product's enthalpy is greater than the enthalpy of reactants. So in such cases, enthalpy change or internal energy change is positive in nature. Whereas in the case of exothermic reactions, products will have lesser internal energy than the reactants. The difference amount is liberated in the form of heat. So heat that was liberated is nothing but the difference in the internal energy of products and reactants. So the study of these changes accompanied along with the chemical reaction is known as thermodynamics or thermochemistry or chemical energetics.